So in this video, we are going to look at the Accelerated 7, Unit 6, Lesson 19, Practice Problem Number 1. The students will be asked to calculate the volume of a cylinder and a cone that has the same height and the same radius. Now, notice there's no picture here, there's no visual. So one thing we encourage the students to do is to sketch a cylinder and a cone that has the same height and same radius. And again, their drawing is not something they're graded on, but it is also something that will really help them if they sketch a visual. So we know we have our cylinder that has a height of 5 centimeters. So I can indicate that here, as well as my cone that has a 5 centimeter height. So I can see the heights are the same. And then the radius is 2 for both. So here's our radius, half of the circle of the base. So half radius is halfway across the circle. So again, we review with students from prior units that if you're looking at a circular base, the radius is half from the center. Now, just a note, sometimes the questions will give the diameter. So if this question gives the diameter instead of the radius, the diameter goes all the way across. Okay, so that would be diameter all the way across. Students could just cut this in half through the center. Okay, all the way across through the center. So if the students were given the diameter, let's say they were given 4, they need the radius, they could just cut that in half to find the radius. And there are several questions where the students have to do this. So in this case, we're good because we have the radius. So we don't have to worry about cutting it in half. Okay, 2 centimeters. And we know the students learn that the cylinder is very similar to the cone. They have a relationship, and that relationship is that the cone is 1/3 the size of a cylinder that has the same base and height. So if I were to take this cone and stick it inside the cylinder, 1/3 of the space would be filled, they would be 1/3 of that size. So we use the formula for cylinder. We have our radius squared. We're going to multiply that by the height and pi for this because the circular base. And this can be done in any order. So this is because of the commutative property. You can reorder. We could start with height, then radius, then pi. We could start with pi, then radius, then height. Or the order doesn't matter. So we fill in what we know. We know we have a radius of 2. So 2 squared. We have a height of 5, and we can use 3.14 for pi, or we could leave it in terms of pi. Now we're going to talk about that in just a second. Now our cone is the exact same thing, but 1/3 of the cylinder. So we could look at this as 1/3 of radius squared times height times pi. Okay. Or students could look at this as radius squared times height times pi divided by 3. Okay, so they could just do 1/3 times radius times height times pi, or they could do radius squared times height times pi divided by 3, because 1/3 of is the same as divide by 3. Okay? All right, so now all we have to do is plug in what we know. So we've already calculated the cylinder. We have 2 squared, which is 4, times 5, and that gives us 20. Now, that is before we multiply by pi. So sometimes students can express their answer in what we call in terms of pi. So if the directions say in terms of pi, or pi, we could just say the answer is 20 pi, and that would be acceptable. Now, if it doesn't say in terms of pi, or it says use 3.14 as an estimate for pi, then students would just do this last step of multiplying by 3.14 or pi. Okay, and then that would give us another approximation. Again, pi is an estimate, so there is no exact answer for pi since it's an irrational number, but we use 3.14 as an approximation for pi. So we could say that the answer could be about, and we can use that little about squiggly line, 62.8. Now, if they use the pi button, they might have a slightly different decimal, and they can round to the nearest tenth or hundredths or even whole number. This would be centimeters cubed. Okay? Now, the cone. Once we've done the volume of a cylinder, the cone is just 1/3 of that because the height and the radius are the same. So essentially they're the same shape. It's just that we're missing some of this cylinder because it's a cone. So we could work out the steps all the way through, or we could do 20 divided by 3, and we could do 20 divided by 3, which would be perfectly fine to do, which would be 6 2/3. So the answer for my cone could be 6 2/3 pi in terms of pi, if we were expressing our volume in terms of pi, or we could multiply that out, 6 2/3 times 3.14, which is going to give us about 20.9 or 21. So we could round it to 21, or we could say 20.9. And students are permitted to use a calculator to check their work. We do have the pi button on the calculator, so students could come over. We use the Desmos calculator a lot, which is a nice tool. So I could open that up real quick, and I could just pop into my Desmos calculator, and I could just work out the math just to make sure that I did this all correctly. I'll do a little split screen here. All right, so I know that my cylinder is radius squared, which is my 2 squared, and I'm multiplying that times my height times, and I'm going to use the pi button for this. And you can see 62.831585. Students would have to round, and in this case we rounded to the nearest tenth. So you can see that our answer is 62.8, which is 8/10. And in terms of pi, it would just mean instead of multiplying by pi, I could take pi out, and just do 2 to the second power times 5, which is 40, and put the pi symbol at the end, indicating that we are not finished, but the answer could be 20 pi. Now let's come over here to our cylinder. Now we know already the answer, but let's work through the steps. Let's do 1/3 times the radius squared times height times pi. 20.94, which is what we estimated as our 20 9/10, or we could round this up to the nearest whole number and say the answer is 21. Now, if I want to leave it in terms of pi, I can take out that decimal and see that I have 6.6666667, which is an irrational number for 20 divided by 3, or 20/3. And that would be another acceptable answer, 20/3 pi. So again, sometimes students might want to work it all the way out, but sometimes it's okay to leave it in terms of pi. Since pi is an irrational number, there's never really an exact number for that. We're always sort of estimating when we're working with pi. This is how they would calculate the volume of a cylinder and the volume of a cone.